Welcome, everybody. Welcome back, and welcome if you missed the opening session and you're just joining us. I'm Gary Fisher. I'm with the Project Production Institute, and I'm going to be introducing this segment on how do leading companies implement and benefit from production management. So I'm going to lay a little groundwork and then kind of turn it over to others to show you some real good stuff. So as I mentioned in my opening slides, it's going to be a little bit redundant for a few of those of you, but in case you're new, when I was at Chevron, I was looking for validation that our system was performing. It's a system that I helped design. And these were the results. We found that surprisingly only 9% of the industry projects in upstream had met cost, schedule, and attainment. Really poor results. And this isn't unique to Chevron. This is an industry-wide thing. I could use any segment, any set of data. There have been multiple studies done that show that these are typical performance for the construction industry. And as Ed pointed out in his opening remarks, this has been a problem systemic in the construction industry for the last 50 years. We've been flatlined while manufacturing has improved their productivity and their performance by like 500%. So in spite of all our best efforts with the advent of 3D CAD, critical path method scheduling, front-end loading, advanced worker packaging, our production efficiency has been flatlined. So, I always just thought it was the knuckleheads that weren't using the system, but I turned out to understand that it was actually the system itself. And I did some really deep dive into the history and the roots of the project practices that we have. And this is what I found. We go all the way back to a guy called Taylor that had a belief that workers were lazy and you needed to separate people from planning from working because the workers would never load themselves up with a lot to do. So you had to have people that planned to work for workers and just hand it to the workers and let them do it. Man, that iron triangle on the right-hand side, I remember my first year as a project engineer starting with Chevron, that it was ground into me. There's a absolute hardwired relationship between scope, schedule, and cost. If you want it to cost less, you got to cut scope. If you want it to go faster, you got to spend more. And then I came to see that these things aren't actually science. They were theories that were put out there. But instead, if you see on the next slide, we built a whole project management system on this basis. And it's very focused on what we do, when we want to have it done, and who we're going to have do it. And that's Chevron's project management system that I helped design was all around doing those three things really well. What, when, and who. But what's missing? It's the how that work will get done. And we were living in this place on the left-hand side, the schedule that should happen. I actually thought the schedule was a plan. I remember telling people, your project execution plan is not complete till you have a schedule that goes with it. And that's all around what you want to happen with dates and progress. But the reality, and this is where project production management lives, is that right-hand side. There's a production system here, and it's going to dictate what's really going to happen. And that's all about project production management. If you go to the next slide, here's what's really going on. Instead of the slide that I showed you on what project management is, we had a product design, which is the scope or whatever it is we're going to build. The process design, which is the techniques, the way we will go about making it. It's the how it gets built. The capacity, those are the people and the resources that are used to build things. The inventory, that's the piles of stuff we have throughout the project that are waiting in queue for something to happen to them. Could be pipe spools ready to be hung. It could be data sheets ready to be checked. And then variability, which are things that don't happen as we expected, which projects have a lot of. And projects are unrecognized production systems. And that's why not even seeing this, by not even being aware of this on the right-hand side of that equation, we're just missing out. And the way I designed the Chevron project management system, it was determined to fail by these rules. And this is the science that governs project systems. A key relationship is called Little's Law. It's cycle time equals work in process divided by throughput. And think about it. Most sciences have a three variable equation that govern them, like F equals ma, time equals distance divided by speed. And I had a terrible time getting my head around this. How can more work in process actually increased my cycle time, because the system we designed, the systems that we all use, because they're based on the same foundation, generate massive amount of work in process through the project. Because hey, all the work's got to get done, right? So if all the work's got to get done, why get a lot of things going, get them all started. And instead, so by definition, we're causing the projects to fail. We're causing that poor performance. And it's held with it. What really happens on the next slide is that rates drive the dates. The rates at which work are being done actually drive the dates that are generated. And dynamic projects required rapid replanning. Remember that variability that I talked about? Well, that creates the dynamic nature of projects. And if you're not able to rapidly replan, you're going to fall behind, and you're going to go deeper into the hole. And you know, even though we pretend like we have planners that do the planning, the reality is the people doing the work do the real planning. I can't tell you how many times I walked around a job site and said, "Oh, show me your schedule." And they go, "Yeah, that's that pile of stuff over there. That's stuff on the wall that we never look at. Here's what we're really doing." Sound familiar? And then follow the science. So what is this science? Go to the next slide. It's operation science, is the project science. I had no idea that there was a body of science that governed, that described how production systems perform. Now, if you're an industrial engineer, you're going, yeah, everybody knows that. This civil engineer didn't get any training on that, either formally or when I started working for Chevron in the project world. So operation science is the project science. You're going to learn all about that today. And project production management is applied operations science in projects. Now, there's some key relationships that go with that. We're going to try to have a little bit of fun right here and engage you all into what these relationships are. Now, remember, you're the folks that are leading the projects around the world, so we want to kind of test your thinking about your understanding of how these things are related. Cycle time is simply how long it takes to get things done from start to finish. Work in process, or is anything started but not finished? Okay. Throughput is the rate at which work is done, like diameter, inch wells per day, or number of terminations per hour, those kinds of units of the rate of throughput. And utilization is how much of a capacity is used. Think of it as if we got a crane, how much are we using it? 90% of the time, 50% of the time. Even craft productivity is a measure of utilization of the craft. Haul road congestion, or shipping it, you're shipping things from point A to point B, and how much of that shipping capacity are you using? So that's utilization. And the science informs us about the relationship between these key factors and the things that drive any production system. So I want to run this little experiment. We go to the next slide. We're going to take a poll. And so this is kind of new. You'll see this throughout the day. You can either scan the QR code on the right-hand side, or if you go to your chat window, you'll see this link. Should be able to click on it, and then you can take the survey. Okay, so QR code or link in the chat window, take the survey. Let's go to the question. Go to the next slide. We're going to explore the relationship between utilization and cycle time. So utilization is the percent of capacity that's used. Remember that, how much of that crane we're using. And cycle time is how long it takes to get things done. So notice the numbering goes 1 and then 2 below and 3 above, 4 below, 5, 6 below. So put in the number where you think that relationship is, which one best describes that relationship from your point of view. And then we'll see the results when they're ready on the next slide.
I got a request to go back to the barcode. Let me just do that for a second.
Okay.
Some folks might still be working on that. Might take a little while for people to get that.
I understand. This is new to us all here, and
No,
I've been in symposiums where I was fumbling trying to find my camera and say, now how do I do that QR code thing? And took me a while to find it.
yeah, we'll take a minute to do that and then move on down the line. So while we're doing that, when you did this test, did you get it right?
No, no, I didn't. I had no idea what the relationship was. In fact, hopefully I was able to explain what these factors are adequately, but I couldn't even understand what utilization was. It's like, what? And what's throughput and work in process?
Yeah.
All those terms were so foreign to me. Cycle time was the only one of those four that I actually understood. It was kind of intuitive. It was similar to things that we already did, but work in process is such a key term and a key definition in operation science that, and it took me a while to get my head around that, huh? And what it means and why it's necessary and how it's used and how it can negatively impact a project.
Yeah, it's interesting there, these are fundamental relationships that everybody should understand, like gravity. And then what we'll find, be interesting what we find, that if everybody has a common understanding from the answers. So I think we're good on the barcode.
Okay.
So now let people pick.
All right. Pick the one that you think best defines it, or if you have no idea, put in 6.
Right. Yeah, we introduced actually option 6 after doing it a few times because it was obvious that people are saying, I don't really understand. So that is certainly an option.
Yep. So how are we doing on the results?
Let's have a look.
Nobody's answered the question.
I doubt that. Oh, here we go. Might take a little while.
In the Q&A, Ed saying is the assumption that all the material are there.
Yes. The material's all there.
Okay. Thank you.
Good question.
So we're either not getting polls or we're not getting results.
Yeah. Dang it.
Ed, please right click and reload.
Okay. Reload. Oh, there's some action. Whoa.
Oh, okay.
Here we go. There's some results.
Awesome. Well, that's good.
Oh, not many people.
A couple of honest people there don't know.
Right. Let's see. Let's go back to, Eva, if I go back to look at the answers, will that erase this or can I come back to it?
You can come back.
All right. Let's go back and just see. So 3, it's actually kind of what it looks like, Gary. 3, 1, and 2. Yeah, we're the top.
Or 1 and 3, 1, and 2.
All right, come on, go back. I had this happen before. I need to stop the share. And give me a second. Let's see if I can. Oh, there's another answer. So we still got a few coming in. I don't know what's going on. It's not. Let me get it. It kind of gets stuck on this slide and it's not responding. Oh, there we go. Okay, so let's go back then. This should work. There we go. What do we say? 3, 2, and 1?
Yeah, interesting. And there's a fair amount for 4. 4 was my answer when I did this for the first time. I thought, hey, man, you get more utilization, you got to shorten the project because, hey, crap productivity, I want people working harder. That's going to take less time of people doing more work, right? Well, let's look at what the correct relationship is based on the science in a couple of slides later here.
All right.
See, it is.
Whoops, went right past it.
Number 3.
There you go.
Utilization increases. There's a turning point there, cycle time will go out. Interesting, huh? For a project person, that was counterintuitive to me completely. And we designed many of our systems to actually increase utilization right up to the max. Or
Well,
think
another
about it
takeaway,
differently. We'd have to pick, how many cranes do you want on site? Well, I don't know. I think it's 2. Well, how do you think? I think it's 3. And we had no science at all to determine how many cranes that we thought we really needed to do the work that we needed. And we watched utilization of the cranes. If they looked like they were sitting around, we had too many cranes. If we had all the cranes were busy all the time, then we must not have enough. Let's get another one. All right, let's go to the next relationship. Next slide. We're going to look at the relationship between work in process and cycle time. So same drill as before. You can use the link in your chat or the QR code. And we'll see what you think. Now this thing's humming. That's fun to watch the results come in. Looks like one's the clear leader. So as WIP increases, cycle time goes out. Very good. That's very close. Let's go to the best answer. Actually, you need some WIP, but there becomes a point where it becomes deleterious, and then it starts increasing cycle time. But you do need some WIP in the system. You can't operate with none. Okay, so that's good. So the one thing I want to talk about now is variability. If you remember those 5 levers I showed you, and I talked about variability, it just happens, lots of stuff happens. I know we assumed it's just the way it is, and we had to have workarounds for all that. There's really nothing you could do about it. But of those 5 levers, variability is just really the most insidious. And again, variability is things don't happen the way you expected or planned them to happen. You get surprised, things go haywire. And here's what we do in projects to protect ourselves against variability. We generally, and we could use any kind of part of a project or a whole project, engineer, fabricate, deliver, install. Let's pick fabricate. We give the fabrication team the job to get it done because we ask them to optimize what they do. Well, what do they want sitting in front of them to be able to do fabrication really well? Well, they want all the materials, they want all the drawings, they want everything that they need to be able to fabricate, so they're insulated from any variability coming at them from the upstream side, right? That's what we all do. That's human nature. As a construction manager, I wanted all my materials that I needed for that job sitting in the warehouse, and I drove that project to do that. And I didn't really realize or even think about what are the impacts of that accumulation of material waiting on me to do the construction work, sometimes years in advance. And that means I had to store it, I had to babysit it, I had to maintain it, I had to keep track of it, and somehow it kept getting legs, and people in the refinery would borrow it to use it for something else. I had to replace it. And then some of it it became obsolete through design development or whatever, and we had to replace it. So the true cost of putting all that material and having that available to me so I would never have to wait on material was huge. And even the worst part was I tied up cash. I tied up cash years in advance that could have been used to fund another project and another refinery and generate income. All because I needed to protect what I was going to do with construction. I was only responsible for construction. So there's a direct and a real hidden cost here. And this is huge. And the more that those cylinders become, the bigger they become, the more work in process we have. Remember Little's law. It means it's going to take more time to do the work, more time to do the work, more cost, more time means lower return on investment. That's what we do. And that's why the systems that we see perform the way they do. They're designed to have substandard performance. So I talked about the PPM framework earlier. I want to revisit that real quickly on the next slide. This is what we're going to be talking about in this segment, is really fleshing this out and looking at people that are actually using it, putting to work their experiences, both in design and in the construction or fabrication. And like I said at the beginning, that this is all based on that gray bullet in the middle. It's all operation science based, dealing with the production system. And the gray ring around that is really the project production framework that you're going to hear about in this session, around designing and optimizing the project production system. This is the what will happen compared to what you'll want to have happen on the schedule, and then controlling that system in a completely different way. It's not project controls, and we're going to talk about that later this morning or tonight, but controlling in a completely different way. So you have design a production system that's operating, and then you have controls in place, and it feeds back into how you optimize that system over time. And that's really a loop that happens to deal with the dynamic nature of projects. So and then once you get that foundation in place, we're going to talk about some of these things later in the day, then you can put to work simulation, artificial intelligence, analytics, IoT, all those things have a solid foundation to work off of and become far more effective. You know, we see often, for example, I saw the great digital application for improving the effectiveness of advanced work packaging planning. Well, so we take something that doesn't work very well and we digitize it to make it work, to make the process work really well, but we're still dealing with a flawed concept. And we got to be careful not to do that. And that's a lot of the kind of improvements that we see around the industry are taking a current practice and making it slick and better, but it's still a current practice. It's still grounded in non-science. So let's hang those things on the real science and get real improvement. So at its core, the next slide, project production management has, well, we dropped a slide there. So back up, please. Project production management has 3 core pieces, and they're going to be discussed this morning, and Ed is going to talk about them in more detail in his remarks at the end of this segment. Designing the project production system, designing the product or facility using computer assisted production engineering or concurrent engineering with the people that are actually going to build it, do the construction, and then control the work and feed that back into the overall system to optimize. Okay, so now I hope you're scratching your head, wondering what the heck is he talking about? What does all this language mean? How does this look like in the project world? And for that, I'm going to hand it off, but I want to reflect on something that we just heard from our neuroscientist, that I need to see it to believe it. Well, that's what we're all about this morning. You're going to see it. You're going to see it on projects, and hopefully we can get you to also then believe it. So I'm going to hand this off to Roberto as a facilitator for our next session. Roberto brings 25 years of experience in implementing project production management. So, you know, who's better than him to assist us with this application session? Roberto also contributes regularly as an instructor at the PPI educational program, as well as with technical papers to further develop the PPM body of knowledge. You are in really good hands with Roberto to lead us through this and facilitate and moderate this whole segment. So Roberto, it's off to you.
Thank you, Gary, for the introduction so much. I really appreciate it. So it is really my pleasure to be your facilitator today and be able to introduce several experienced speakers from many leading companies who would share with all of us why they have adopted project production management, how they're implementing it, and how they're benefiting from it. This morning, we have 4 speakers. We have about 2 hours a 2-hour session. The focus is going to be on how PPM is being used in design and engineering. The afternoon session, which will start at 1 o'clock after a half an hour, 1 o'clock Central Time, after a half an hour break, will concentrate on the application of project production management to improve supply and site construction. I want to highlight a couple of things. Each speaker, each of our 4 speakers, has been allocated a total of 30 minutes. 20 of these 30 minutes are going to focus on presentation, and the remaining 10 minutes or remaining available time within these 30 minutes will be for questions and answers. All of you attending, our audience, please remember that at the bottom of your screen, you have a Q&A feature that you can use to put your questions as we go through the presentations or even during the Q&A session. Okay, for a brief message to our speakers today is to please follow my direction as it relates to when to show your video, when to show your screen, turn on the audio, and so we ensure a smooth transition through all the stories that you're going to bring to us today for our audience. Okay, this is going to be fun. I'm personally looking forward to hear you all. So let's get it started. Our first session today, and without further ado, we would like to welcome and introduce our first speaker, Mr. Pathman Arulampalam. So Pathman, if you don't mind, please proceed to share your video and enable your audio.
Hello there. Can you hear me okay?
Yes, great. We can also see your screen, so we are doing well.
Great.
Let me see here 1 second. Yep. Okay, thank you, Pathman. Welcome to the 2020 PPI Annual Symposium. Thank you very much for being with us today. But let me please take some time to properly introduce Pathman. Pathman is currently the Senior Manager, Optimization and Integration from Hess Malaysia Exploration and Production. He has been with Hess Corporation for the last 15 years, a significant amount of time, in a variety of roles, including being involved or have led implementations of project production management at Hess. Pathman is both a member of PPI's Industry Council as well as a member of PPI's Energy Working Group, which was introduced in our introductory plenary session this morning. Knowing Pathman, I have no doubt that you will find his story of a strong interest to you. Okay, so remember please to use the Q&A feature if any questions. Pathman, I think this is over to you. I will be making, if necessary, any verbal cues during your presentation in terms of time control. Thank you.
Sure. Okay. Thank you, Roberto, for that kind introduction, and thank you for having me today. So good morning, good afternoon, and good evening to all of you on the call. Let's get straight to it then. So hopefully my slides will start to move here. So here's our agenda for today. In a nutshell, I'd like to share our story here with you, both the good as well as the challenges we've had in our deployment and implementation here in Malaysia. So let me preface everything initially by saying that as a company, Hess has experienced both tangible and intangible benefits from implementation of PPM. But you know, if you choose to implement it, do talk to those that are on the call here today. It's not something you should go into unless you're kind of all in, so to speak. Your top leaders are all in as well. So as a famous quote goes, you know, do or do not. There is no try. It's not as good as it's not as an Einstein quote, but it's one I like. So just bear that in mind as we go along, or if you choose to deploy yourselves. So allow me to give you a bit of context how PPM came to be in Hess. It has its roots in the plains of North Dakota and has now sprung up in the Far East here in tropical Malaysia. In North Dakota, the implementation was in the Bakken unconventional shale play. So unconventional shale plays are generally onshore oil and gas developments of large volumes, developable by hydraulic fracturing primarily. And they generally require a high number of wells per given area. In Hess and other places, the development of these plays have been coined, so to speak, well factories. In other words, a manufacturing process or production system with materials and knowledge as input and production wells as output at the other end. So as I said, first adoption was in North Dakota Bakken. And that was led by Dave McKay, who may be on the call today. He's won previously a PPI Industry Recognition Award. Dave's now retired from Hess, and he's a modest guy, but he, along with the likes of Shannon Bielek and Michelle Naring, kind of started this for us, and it's one of Dave's legacies at Hess, which has had a big impact on how we work. So the introduction and subsequent growing pains of the PPM deployment kind of resulted in it became sort of the DNA for some of us as we went through it and then applied it to other places. Now, it didn't happen overnight, mind you. Some of us, including Dave and Shannon and Michelle and a couple of others on the call probably have battle scars, and it probably took a couple of wrong turns and false starts. But I think we're already, if not already, soon to celebrate our 10th anniversary of PPM implementation in the Bakken. So after the Bakken has expanded to other similar unconventional plays, first of all, in the Utica play in Ohio, I saw that Joaquin and Kelly are on the call, so they are very familiar with that implementation. And then also unconventional new business in China. So building on these sort of onshore unconventionals, then sort of enable Hess, we leverage these deployments and implementations and the learnings that came out of those deployments to then say, why not try this in major offshore capital projects? So here we are in Malaysia doing that today. And so that's kind of the topic of my talk today. So why did we choose to do it here? So I think that the three main reasons that sum it up. The first one is a belief that there's a better way to do things. So, out of respect for people, we should provide them a means to do something in a better way. So if we have an opportunity to try something, then, by all means, why not do it? There's also a factor of, in most workforces, I think, some anxiety when you come to work, what should I prioritize? When do I need to finish this? So who is waiting on me? What will I deliver? What does the next person receiving need? What do I do today that meets my targets for the project? So all these things, out of respect for people and trying to give them a better way to work. So that was the first reason. The second one, here in Malaysia, I guess you would say we're kind of in era 2 development model. So dates were being set without consideration of the rate at which work gets done. You heard just before about, the rate should drive the dates, and that wasn't happening. So, if we do not acknowledge that the rate of work drives the date by which something can be done, then there's no other way around. We should not be surprised if our delivery is late. And finally, with transparency, this one of the biggest hamstrings or the biggest enemy of an organization is everyone having kind of a different set of ideas of what the priorities need to be, and how things should happen and in what sequence. So we kind of wanted to bring some more transparency, some more collaboration to kind of how work was getting done. The last one is maybe something that everyone can relate to. We have complex processes. Here in Malaysia, we have our own HES internal processes. We have our regulators process. We also have our partners process. So you've got multiple dimensions to having work done. So you kind of layer all of that, and then you add on kind of the operational science that we just heard about, and the obvious complexities become very apparent very quickly. So those are kind of summing up kind of why we did it here, and in fact why we do it at HES. So try and get my pointer here. So when we look at continuous improvement, we may often ask ourselves, so what's the gap? It also proves useful to ask the enterprise this question, involve them in the thought process to make the case for change. So as I mentioned, in HES Malaysia, we were doing capital projects through project management, which, as you also saw previously, kind of uses these three levers here to influence cost, time, and cash. So the direction we wanted to take, or what we wanted, was for our major capital projects here in Malaysia to get access to more levers. So in particular, we wanted to focus on the product design. So kind of the types of wells, the types of facilities, the types of pipelines we designed, and also understand how work is done and what handoffs occurred. And that's kind of where the process design comes into place, and what's the duration of the activity. So how long does it take to do work? What's the rate of work? And the third lever we wanted to focus on was variability. You heard a bit about that just now as well. So specifically for our case, we wanted to understand what was the main cause of variability. We hadn't really looked at that in any shape or form. And we had many projects going on at the same time at different stages of maturity. So, some of the questions were, does the same type of variability impact different projects in the same way? Or was each project subject to its own unique set of variabilities? So let me share here some of the considerations we made when approaching deployment in North Malay Basin. And I would say that up to this stage, I think the implementation model at HES, it may vary from asset to asset, but it's generally the same in the big things we try to focus on. So one of the things we always ask ourselves at the start is sort of scope. So we have, in our case, we had multiple major capital projects ongoing, different stages of maturity, but multiple things going on at the same time. So should we deploy it in one project only, or should we deploy it in all the ongoing projects? Another question we ask ourselves is, what disciplines, what functions should be involved? When we talk about major capital projects, you may have a mental model of engineering design, procurement, fabrication, hookup, commissioning. But I think for us, we looked at, should we involve like the whole value stream that's involved to get the product to the sales point, in this case, a well on production. So in this case, I'm kind of talking about the pre-development work that has to happen, whether you call it feed or whether you call it subsurface modeling, or whether you kind of call it the technical specs that you're going to put in your bid for the fabrication contract, as well as the drilling and completion work at the execution side, even commercial and legal work. Why not? If one part constrains one other part, you're still going to end up where your project is late. So we kind of consider these things as well. Another big item was, do you do one part of the value stream or do you do the whole thing? So our deployment and implementation model at Hess has always been kind of one of transferring knowledge to the organization. And much as anything is to make it sustainable. So we want self-perpetuating capability in the organization, but the level of involvement can differ. So generally at Hess, we have roughly 3 groups, sort of one group or 1 or 2 individuals that kind of lead the PPM effort, and they are kind of very deep into it. Then you have some of the functionals, we call them super users in each function, maybe 1, maybe 2, to kind of help the rest of the function when required. And then you have the last group, who are the ones who do the work. This last group is key. Key to process design, key to understanding variability, as they are the ones closest to the work. So they understand how work is done. They are the ones who make decisions on a given day or any day as to what gets selected for work and why. And to have them involved and to get them into the PPM thinking and behaviors is so critical to the success of a given implementation. Finally, when we go into process design, so we go and focus on duration of activity. We focus on constraints. We focus on what's going on upstream or downstream of a particular activity. How does the work flow? So we're not talking about when can it get done by. We're not setting dates. We're just kind of looking at how the work gets done, the rate of it, the rate of that work, and so on. So implementation means putting out what the gaps are, as I said earlier. So we deployed in June of 2019. Obviously, there have been some challenges, as always are with deployments. I've been involved in a couple now, and they generally seem to fall in these buckets. So individuals who are looking for, what's in it for me, what is this going to bring me versus kind of the we and how is it going to benefit the whole. There's obviously a new adaptation of a new way of thinking. So there's an unknown degree of, there's the unknown, first of all, and then there's a degree of, I would say, uncomfortable feeling about change, as you would well realize. People generally will go through a lot of stages as they go through change. And then the last one is for me really key. So leaders in the organization really have to lead. And I'm not, it seems funny to say that, but they really have to stand up and own it. So even though, when you go into something new like this, you may not fully understand it, but I think you got to act yourself into the behavior. So you can't think your way into the right action, but you can act your way into the right thinking. And by doing that, it eventually starts to click as you get into it. So some of the highlights we had here, I would say, over here in Malaysia, it's a culturally open-minded place. They are pretty they absorb things really well, and they're very open to new ways of thinking. And also, additionally, when we were mapping things, you could see a lot of literally light bulbs go on, kind of moments of real understanding between the teams working. And it's like you haven't seen your process yet until you actually kind of look at it on a wall with a bunch of sticky notes and lines drawn all over the place. And it looks like a mess, but it actually really makes sense once you have it all up there and you have people talking about how the work gets done and why it gets done this way. And that's a really powerful thing. I said initially we had some tangible and intangible benefits. This is one of the intangible benefits, having everyone see, everyone understand how work flows, how the production system behaves. So what does the data tell us? So as I said, we implemented in June last year. So there's a lot of colors here, a lot of numbers. I won't get into too much of that detail, but I did say earlier we wanted to focus on variability as one of the levers we wanted to focus on. So here's kind of a graphical representation of the variability that we see. So it would be a mistake to say that all our projects are impacted in the same way by variability. What we saw in the data was that each project, as you break it down from the total of everything that was going on to each project, you could see the variability does differ. So we focus on systematically identifying sources at different levels. So cutting the data from different projects to different phases in that same project, whether it's pre-development or execution. So for example, here you can make out that there was much to learn about being able to effectively estimate how much time a task will take. So underestimated duration, this big bar here. So all that means is, when we were designing our process, what we assumed for how long something would take was way under. And you could say that's generally human nature. We tend to maybe not estimate things we tend to be a bit too optimistic sometimes when we estimate, and we think the rate of work will go a lot quicker than it actually does, because we're not thinking about the variability that's impacting the system. So in the same way, we can use all this data to look at, okay, instead of trying to tackle everything that's going on, this gives us an ability to say, okay, let's focus on a few things. So it's kind of a very surgical approach versus sort of a blunt instrument, sort of trying to get to everything. So with all this, so you may be thinking, okay, so what? So why is addressing all these things like variability important? So I'll try to hopefully say, through these charts, kind of give you some of those answers. So on the first chart here is just kind of measuring our trend from the time we deployed this to current, about how good we were at doing what or executing what we planned to execute. So we can see as we got better between our ability to reliably plan, and that means allocating our capacity in the right way on a daily or weekly basis, and addressing some of those unexpected things that occurred, the variability, then we were able to then improve how we plan in the next 5 to 10 days. So this chart is basically showing, again, from the start of the deployment to now, kind of what the trend is about how well we plan and control the next 5 to 10 days out. So by doing that, we are able to give ourselves a bit more of a better commitment, or a bit of a more definitive time on when we, or time of when we're going to complete our project. So the last one, this last graph is trying to show that. So in essence, the closer the yellow line gets to the blue top line here, we are trying to say that if our work is being planned and executed in the right way, and we are controlling the work, planning the work in the right way, then the amount of difference between when we're going to finish the project and in terms of a forecast to when we actually are going to finish should start to close. So that's all what we're trying to do, is sort of close the gap between where we want to be as far as a finish date and where we are as we went along the process. So you know, again, the charts themselves, a lot of may not be may not be totally understandable if you're new to this, but I think the power of this is that we can see it. So we're kind of no longer at this stage relying on, yeah, I think this is happening because maybe, probably, so it's not subjective anymore. So we have data, we have facts, we have the ability to take out the opinions or the subjective opinions and be more objective about how we're doing, what our performance is, and kind of make future decisions on that. Also, Hess is not trying to get rid of variability. That would be nice, but that's simply impossible. You know, we're trying to put in place a approach to reduce it, to reduce the variability, manage it effectively without having to use too much buffers, if you like, excessive buffers that would result in cost, and you know, again, we don't want to have excessive inventory or things like that, because that's just money sitting there. So we want to optimize, as you all do, on our cash. Okay, so these last two slides, just want to kind of summarize some of the things that we've looked at, reflected on after about a year and a half of implementation here. So it's a process where you're continuing to you continue to learn. So you're trying to get to a better way. So again, like we said at the start, one of the reasons we deployed it here is because we knew there was a better way. We wanted to bring a different set of thinking here. So now the team have access to more levers to optimize what they're doing. I've said here that the pandemic kind of unexpectedly showed the team here the value of PPM. So what do I mean there? So, you know, what we experience here may be common to what you have, but we had shutdowns here of yards, interruption in supply chain, interruption in ability to do work offshore. So having access to those levers became more important, either design adjustments, depending on where a particular project was, or relooking at the process design to change priorities according to what work was available, given what yards were open or what supply chains were working. And with all this, we're slowly getting some recognition among the peers here in Malaysia about a new way of managing development. So we're doing things that in a way that's seen to be, we're bringing performance that hasn't been seen before. So we're building wellhead platforms in shorter durations. We're doing certain brownfield projects faster than before, or more reliably, I would say, maybe than before. So we are setting targets. We're meeting those targets. However, yeah, thank you. However, we still have bad variability. We still miss targets. So that's still the nature of this. So we've got to continue to be focused on improving as we go through each cycle. And as you saw before with the underestimated duration, we didn't understand our process as well as we thought we did. So these are some of the lessons we're capturing as we go through. So in the final minute, final slide. So I think the one thing I want to pick out from this one is the last point there. As part of this effort of deployment and implementation of PPM, so the education of the leaders and even those who are doing the work, that's the critical part. Do we understand why we're working a certain way? Do we understand what the production system is doing? And when we're deploying these things, do we know who to ask and what to ask about a process or how it works? So I guess I'll leave you with managing the work. That's not the same as improving or optimizing our work. So bringing PPM into this environment here, offshore major capital projects, moved us from that managing of the work to improving and optimizing our work. So I will pause there and be happy to take any questions.
Padma, thank you very, very much for such an inspiring story, including your journey, Hes's journey, your personal journey, right? You have been part of that, and how you have strategically targeted the application of PPM in Malaysia. Very, very impressive. We do have actually several questions for you, but conscious of time, we probably can go through a couple of them, okay? So I will please request that you try to answer very, very straight to the point, if you will. The first question is, in an earlier slide, you indicated that the scope choices you had to make, right? Presumably you choose multiple projects, included all functions, and included the full value stream. Is this correct?
Yes, that's right. That is correct. So so the scope did include all projects, not all functions, but most functions. Yes. Okay.
Then the same person is making a follow-up question. So let's go to that. He says, secondly, will you make the same choices now?
Absolutely, yes.
Okay, thank you. There's another question that it says, it is impressive how you have been able to identify sources of variability. This is a very interesting question. Can you please elaborate a bit more on how you have done this and sustained it over time?
Yeah, I mean, I think how we have done it is just through the behaviors and thinking and having those who are doing the work give that input. And so we're recording the reasons things are not getting done. And then what we're doing then is surgically, as I said, looking at, okay, so we underestimated duration, and it happened a lot in this particular process in the pre-development side. So then we need to go back into that and for the next project and adjust what we're thinking, or we need to go and talk to the stakeholders that are impacting and causing that variability, and look at, okay, can we design the work in a different way?
Excellent. And a final question for you, Padman. It seems to be a question for clarification, so let's address this one. Is this data, the data you have presented, construction focused, is the question, or is the PPM approach applied earlier, such as in engineering and the execution of engineering work?
Yeah, so when we looked at where in the value stream to do it, we did the whole value stream. So it starts with the as early as the subsurface side of things, if you're familiar with oil and gas, and the I call it the design of the subsurface, or the design of how you want to deplete a particular field, all the way through to bringing that well online. So it impacts not only just I'm not sure what the word was, but not only just the construction side. It also involves the I call it pre-development, but sort of the design and even sort of feasibility part of how you would do a development.
Excellent. Thank you so much, Padman. Conscious of time, I think we need to move on. And so thank you so much for being with us today. Keep up the excellent work. Thank you again. And we now transition to our next speaker. So please allow me to introduce representative of PT Tripatra from Indonesia, one of the largest EPC contractors in Indonesia. We welcome Pak Dira Nandana and Pak Aries Suswendi. If you can please proceed to enable your video and your audio. Thank you so much. I know it's very late for you, and as well as for Padman, who was joining us from Kuala Lumpur. So thank you for joining us. Pak Dira and Pak Aries will share with us why Tripatra has actually adopted PPM, how they are doing it, and what they're learning so far, and also what is their vision of the future for their company. But let me share first a few details about them. Pak Dira is President, Director, and CEO of Tripatra, have been with the company for 39 years. Pak Dira, quite a journey, by the way. Pak Dira has pretty much done it all, from engineering to procurement, contract management, business operations, finance, commercial, just to name a few of his previous roles with the company. So welcome, Pak Dira. Thank you. Pak Aries is the Vice President of Innovation and Technology for Tripatra. Pak Aries joined Tripatra in 2019 to bring his vast experience in leading and implementing effective technology and transforming or transformation of project delivery. We are really honored to have you both here today with us. Please proceed to share your screen. I think we're going to start with Pak Dira. So I will confirm that we can see it. So, okay, excellent. Without further ado, Pak Dira, this is over to you now. Thank you.
Okay. Thank you, Roberto. Good morning, good afternoon, good evening for everyone, wherever you are. Hope everyone are well and safe and in good health. Okay, first of all, of course, thank you for the Project Production Institute for providing us the opportunity to share our journey about the project management. I will convey this presentation with my colleague, Aries Suswendi. I think that it's aligned with the theme that we need to collaborate, right? So now even having this presentation, that I need to collaborate with my colleague in this. Okay, let me start with okay, how Tripatra addressed the energy demand in Indonesia. I think as we all know that Indonesia primary sector of national income is coming from the oil and gas sector, and we have and we can see that here it is. I mean, this material was. I mean, this information was obtained from a recent international convention held by the SKK Migas, which is the Indonesian regulator for oil and gas. That it shows that the aspiration of Indonesia that to grow its production to 1 million barrel oil per day in 2030. Whereas at the moment, Indonesia production is about 700,000 barrel oil per day. So I think it's quite aggressive that the SKK Migas has set the target for in 2020. But for us, it's an opportunity. It's an opportunity for us to help to contribute to our nation on this the plan of this target. Okay. Now a little bit about Tripatra. Tripatra is actually started as an engineering consultant. We established in 1973, so almost 47. It's about 47 years. So we start with engineering consultant, and we evolve ourselves to EPC contractor. Predominantly, we are in the oil and gas sector, and now we are recently adding the asset management as in our portfolio services. So basically, we do engineering, construction, project management, supply chain, and currently we also do the asset management. So now the question is why PPM and how did we find it? I think this is quite interesting for us, as I shared before that we've been in the business. It's about 47 years. So we thought that we know so much about the business, right? But I think that if we reflect ourselves, especially on the last decades, then we also realize that it's getting tough and tougher in delivering a project. Actually, the finding of this PPM was started by my predecessor, that he was joining in one seminar in I think in Europe, in London. He was one of the panelists, and on the moderator of that session was actually one of the partners of McKinsey. And after that session, there was having a discussion, and then my predecessor asked the McKinsey partner about the situation, whereas is there any solution that can help us in improving our project delivery. And then the McKinsey partner suggested us to meet with Todd, which is from SPS, but at the time, I think during the very short time, it's difficult, and Todd only suggested to my predecessor to meet or to attend the annual symposium of PPI, which is similar like today, on 2018, and to learn more about that. So then he went there to this symposium, and then I think that what I understand, what I heard from him is that it's so difficult in trying to convince the Todd at the time to allow us to learn about this, because I think at the time it was the view from Todd is that Todd has been trying to introduce this knowledge to EPC contractor, but all of those EPC contractor always say that they don't need that because they know better and they have experience about this, so they don't need any more solution. But then it's interesting for Todd to know that we are coming from Indonesian EPC contractor, and then we would like to learn about this PPL. So that's where our journey starts. So the Tripatra and PPM journey. So I think that we went through a quite common internal situation. I think Pathman also shared similar, right? But I think that we are much earlier than earlier stage than Pathman. So we went through that all this starting from the we don't know about this, right? Unaware. Then the resistance. Then we move also to the open to the exploration. But our expectation that then we will be committed to the effort. So this started on the beginning 2019. So after the 2018 annual symposium, so SPS, which is also one of the, the consultant on this PPM, agreed to come to our country and then provide some early, I think early explanation about this PPM. So then we agreed to adopt this PPM in one of our EPC project, which is just recently started at that time. So we adopt that in one of the EPC project for fuel terminal, and then later on, then we also trying to explore this PPM for on the construction. So basically on the fuel terminal, we applied in the EPC side, and then on the another project on the LNG development, we tried to apply it in the construction, and recently we also tried to apply it in the engineering project on the feed state. So what is interesting for us about after that we learn from this is that so in when we apply this PPM, of course that we have to use the project production control, which is basically the tools for doing this PPM. So and during through the PPC, then we learn more about that, how this PPC allows us to more effectively address the complexity of our deliveries. And then we now clearly understand that about the variabilities. So that's something that we also learn that we never talked about this before, but now we know at least that we have started populating it in the PPC, but it's not easy. That was not easy, right? I mean, because in order to apply this PPM or PPC at that time, if we only apply it to ourselves, which then basically we are the main contractor where we also engage the subcontractor, it won't be effective. So all of the stakeholders in the project should be involved. So if you see also in the picture that we are trying to also educate with our limited knowledge at that time, they're trying to educate our subcontractor in this, and then even within ourselves, we also discuss in how to apply that. So, but finally, that we are able to populate the PPC at that time. Then we also what we learn also on this PPC is that now we understand the impact of our decision. Whether we make it or we don't make the decision, we can see directly the impact, which is also provided on the PPC tools. So that also provide us some new experience that even making decision and or do not make any decision, it can be seen directly in the tools. The other thing that we also explore was the production system optimization. Through the PSO, we learned that the cost impact and the impact and the cost of the WIP to our performance, and then from the chart that we can see that actually it's up to us to choose whether or which approaches that we would like to choose. For example, that on our original policy, we can see actually the cash tied up. This is, I think, the example was done on our piling works. So we can see that on our original policy, actually, that if we apply as what we planned before, it will tie up our cash up to 200, more or less 200,000 US dollar. But through this optimization, actually, it can be reduced to the cash tied up to 68,000. Or on the optimal policy, we can even improve it into 31,000 US dollar. So here we can also learn that the cash tie up unnecessary inventory is not free. That on the comparison on the below table, we can see that basically, actually we can save almost 200,000 of our cash tied up if we are using this. But unfortunately for us at that time, we were not applying this. But now we learned that actually if we apply this, we know that we can improve much on this. And on this learning, that we also know that the PPC or the PSO is not to replace our execution. It's actually to enable us to execute better. This will not replace the engineering or even the construction. It's not. So we still have to do it that well. But with this, with information from this PPC and with the understanding on the variability, we hope that we can perform better, because that is key for us, how to make sure that our execution can perform well. This is just a picture on the fuel terminal project that we worked. Thank God, luckily that we complete that. And with this, I think that I will pass to Aris, who will guide us on this, on how we implement this PPM in our organization. Please, Aris.
Thank you, Mr. Dira.
We have 5 minutes remaining. Sorry to interrupt. Thank you.
Sure.
Okay, thank you, Mr. Dira. So in this point, I'm hoping
I don't think we can hear you, Iris.
can you,
Okay, we can,
sorry.
Yes. Yes.
Roberto, can you unmute?
There's a bit of echo. We were able to hear you and the echo.
Okay, excellent. Thank you, Roberto. So yeah,
Now it's working well.
Perfect. And along the way, when we implement the PPM in the fuel terminal, we continuously validating how effective it is. And that's when we identified, this is part of transforming the way we work. And during that validation, we learned a couple things. We learned there's some gaps that we need to fill in along the way with the process, from unaware, resistance, and this is part of the change management as well. So after in the tail end of the EPC project implementation with the PPM, we identified some of the opportunities that we can be more transparent, collaborative, and that's when we identified the gap that can help us to execute better. So the gap that we identified will help us, hopefully will help us to perform better. Now, we thought about it, what would be the best way to fill in that gap, and we learned along the way that this has to be collective commitment. And in order to collective commitment, some of the leaders in the company, like Patman was mentioning earlier, need to be understanding it further. How can we penetrate better? And that's when we formed the group for PPM Focus Group. The group consisting a few leaders from the transformation, myself including from the innovation and technology, and my colleague who had the operational science background. At the same time with the project management and engineering team as well, and engineering representative. And we work closely with the SBS to ensure that we're following the best practice, and along the way we apply and validate the practicality of the PPM along the way. And that's the part where we identified, we kind of learn more and more the essence of the PPM. So it started from us first. It started from us that in order for us to convince internal team and to convince a bigger scope, then we have to understand, we have to be able to articulate it to the team members. And during that time, keep in mind that we're keeping in mind most of the resources, most of the material references are in English, and some of the, or maybe most of our team members are using a different language, which is Indonesian. So that's the part we also have to realize that there could be translation, a loss in translation. So we have to be able to articulate it in order for people to buy in, right? And that's the time we dig deeper. Each of us, the representatives, trying to learn more and more, and then we can translate it in the way we communicate it, so that people not only doing it for the sake of being forced to do it, but also understanding the reason behind it, understanding the value of it, and we identify which one are the strengths, which one are the weakness that we can do, and along the way we also validate, or being a devil advocate in this case, in order to kind of giving them a hints, or in some aspect maybe pushing to some area that we think that there's an opportunity for us to grow. Some people are respecting the insight. Some people might be hesitate to see that this can be a different way, and not everybody are welcoming, which is expected in some aspect, because we're transforming the way we work. And when you're transforming the way we work, it's kind of breaking the business as usual, which is in some aspect, it's a comfort zone for some people and some of our team members. But based on my experience, I've been in the transformation for the past 10 years, over a decade. And along the way, I learned majority of the people are really welcoming of the changes. Usually the challenge or the hesitate because they don't understand what's in it for them. I think Patman also mentioned that. And what's the implication? What's the bigger picture? What does it mean to our work? How we can impact it or improve the way we do the project, right? And that's the part we found. We feel like this is when the good time for us to go deeper, understanding it more, and at the same time facilitating and helping the rest of the organization by creating an allies, creating a workshop to make sure, or even part of some of the meetings, to ensure that we understand the root cause of the rejection or the resistance, and be on the same page with them. How can we implement it better? Because along the way, they will be our ambassador as well, to explain to the rest of the team members, or even our partner or vendors on the side.
1 minute left.
And what's next for us? So we are shifting. We're shifting from being interested before, interested to learn more about it. Now we're shifting to being committed to scale up on this one. What does it mean by commitment in the Tripatra means? So first of all, well, in order for us to implement better, we also continuously equipping ourselves to learn about it, learn about the PPM capabilities, learn about the use cases that's out there, learn about some of the best practice, and try to validate and apply to ensure that the option or the way that we choose is practical enough. And then on top of that, we also would like to do more collaboration, starting from us first, starting from the internal resources. We collaborate along the multiple different members that might not be common or comfortable to work collaboratively. When we're mapping a few processes that will impact to other team, that will open up the insight and the eyes of some other team members or group that will be impacted or will impact the flow. So we start with the internal first, and later on we also want to do more in collaboration with the vendors and maybe client as well. But again, in order for us to be successful here, we need to convince ourselves that we can do this. And on top of that, each and every one of us, or most people who involved in the project, can be an ambassador to explain it to other stakeholders. That way, each of us are on the same frequency to accomplish the same goal. Plus, moreover, we also complement it with the digital transformation. The starting of digital transformation is similar. Earlier in 2019, myself is leading the program here, and we're complementing the way we do work with technology. And this is the same thing as well. You're transforming the way you do work. And it's very important for us to address not just the technology itself, but also understanding and validating and also continuously improve on the people and the process. And some of the example that we included, for example, we built a couple tool or maybe technology, you can call it. For example, the bottom left is digital control tower that will help us to get a better insight of the project overview, and the data should be fast enough, almost close to real time, so that we can make a better decision, and then everybody are using the same consistent information. So it's no longer waiting for information that need to be processed. The idea is to combine the information and make it as simple as possible and streamlined as possible. That way we can populate the information and make a better decision. And on top of that, the right bottom one is we implementing our own tool for in terms of the material management. Over to you, Pak Dira.
Okay, this is the last slide actually. So basically, it's a message to everyone. I think that we know that we cannot work together. Let's work together. The top chart is basically the problem that we're having in this industry is being also used earlier in this session. So we expect that we can work together in trying to improve this industry. So we hope that with this we can improve our industry, because we cannot do it by ourselves, whether it's client or a subcontractor or supplier. So thank you for the opportunity. To you, Roberto.
Thank you so much, gentlemen. And so we're gonna proceed to stop sharing your screen. Thank you very much for sharing your story and what a journey you have started. And we know that you want to continue with this, with understanding to the next few years based on what you have told us. So look forward to hear more from you in probably next PPI symposiums. We do have maybe a couple of minutes for two questions, okay? We did get several questions here for both of you. And one of the questions I would like to pose maybe for PAC areas is, for the focus groups, are engineering disciplines involved? They are the ones doing the work in question mark. What would you have to say about your focus group?
So engineering is actually one of the transformation team members, used to be the engineering manager for it. So she is involved into facilitating the the project for feed. And yes, they were continuously working closely with the leader of the engineering and even the team member of engineering. So yes, the short answer, the engineering department is involved, and we continue expanding it, their engagement and their participation in order for us to, I think in some aspect, this is collective commitment, and everyone has to be chip in, and they should be part of it. They have been part of the focus group, and then along the way we adjust accordingly what works, what doesn't work, to ensure that it's becoming more effective over time.
Excellent. And one last question. It says, your example of inventory analysis is impressive. Can see what you're doing there, very smart. Being an EPC contractor, assume you can do such analysis during the engineering phase in question mark. Is that the preferred way for Tripatra?
Okay, let me answer that. Yeah, actually, that we would like to have that. I mean, even as what we presented, that we try start with the EPC, then construction, then engineering. So yes, we would like, because we think that even though the people may say that engineering is less complex than EPC, but once we try this, then we learn, right? Actually, in engineering, that there are also a lot of variability that we need to address and we need to plan.
Okay, thank you so much. Conscious of time, I think on behalf of PPI, PAC DEER and PAC Areas, thank you for, again, an inspiring story on the journey you have initiated, and really look forward to having you in future PPI events as much as you are able to. We're now transitioning to our next speaker today. Thank you so much. Our third speaker this morning, Central Time, is Jan Coleman, partner at McKinsey & Company. So Jan, if you can, okay, we can see you now. Thank you. We can hear you too. So yeah, so let me share some details about Jan. Jan is joining us from Amsterdam to share how McKinsey has applied PPM to address specific challenges during engineering. Jan actually holds a Master of Science in Aerospace Engineering, more specifically in Design and Production Composite Materials from Delft University, and an MBA from INSEAD, a very prestigious program around the world. He's also a member of the European Construction Institute's Project Delivery Direction Group and a member, excuse me, of PPI Industry Council. So Jan, welcome to the 2020 Annual Symposium, and thanks for being here with us today. Please proceed to share your screen, and the control is yours from this point forward. I will confirm once we are able to see your content.
Fantastic. Thank you, Roberto, for the warm introduction. I'm hoping you can see this.
Let's wait a few seconds.
I'll make sure I go
Not yet.
to this, and we'll go there. Is it coming through?
Yes. The stage is yours. Thank you.
Fantastic. Right. Thank you again, Roberto, for the warm welcome. Greetings to all those taking the time to join us today, wherever you may be in the world. Like PAC DEER, I hope that you and your loved ones are safe and healthy in what sadly are challenging times. It's an honor to be able to share with you today at the 7th PPI conference. Maybe before I start, a small note on McKinsey, because you might be wondering what we're doing here, as we're typically known as a strategy consultant. And what I just wanted to clarify is that we actually do a large part of our work in helping clients transform their operations, which includes their capital projects. And as part of this, we have a vibrant group of colleagues like myself who are passionate about helping clients improve the development and delivery of their capital projects. My personal role at McKinsey, so my partner in this capital excellence practice has been really to drive excellence in the engineering and execution of major projects, and really trying to find what are best practices and ways to improve the business outcomes of major projects. So specifically cost, schedule, and cash, much like Gary was saying in the beginning. In this effort, I've had the privilege, and I truly see it as a privilege, having been introduced to SPS and PPI, as this was for me, really an eye-opener into what level of control and structural and continuous improvement is possible through PPM. And as Roberto was saying, today I'll share one example of how PPM helped a specific project accelerate the delivery of the engineering phase of this project. I can't share who the client was, as we have strict confidentiality that we have to honor. But just so you understand the setting, in this case, we were serving the EPC on a production system optimization effort for their engineering phase, and I'll get into it in a minute. So what was, and what I'll try and share with you kind of the story or the case example, right, to bring it to life for you what we did. So as I was saying, this is an advanced industries client. So an EPC specializing in projects that consisted of putting specialized equipment in a set of different locations. Okay, so think towers, radars, those types of equipment that had to be engineered to specific site locations. Okay, so this project consisted of delivering several of these design types at over 30 locations. Okay, so that was the scope of the project. It was a multi-year project, several hundred millions of euros in value. What was the situation? So the engineering scope, they had decided to break up the engineering phase and the construction phase in two distinct parts, where engineering was being run as kind of a factory, and then, or at least they wanted to produce the completed engineering design such that they were on stock for the construction team to put in place. That was the setting that how they were thinking about it. But the engineering scope was critical to unlock long lead procurement activities. Now, what was going on when we started to help them was that they'd been working on this for about 1.5 years. They'd run into significant schedule delays. They had just rebaselined the schedule 4 months prior to us getting involved. And even after that rebaselining of the schedule, they were still suffering from schedule slip. When we engaged them, they were describing that both the regulatory environment was challenging, the design inputs that were coming from different stakeholders was complicating things. There was low clarity on the overall engineering process, and it really was challenging to deliver both on the customer requirements and the schedule. That was a bit the context. So this was a project in the engineering phase, struggling to maintain schedule. To the approach we took, we leveraged, we used or deployed product production management, and I'm sure you've now seen, that consists of two major parts. You have the production system optimization part, and you have the product production control part. And this was really an example of the first, the production system optimization. And it consisted of 3 steps. We mapped the standard engineering process, because as I was describing, they had to develop 3 designs across 30 locations. So therefore, each design type, we could map the standard engineering process needed for that design type. And we could do that for design type 1, 2, and 3. Once we'd done that mapping, we modeled the way the production system would work if we understood the production parameters and the characteristics of that production system. So we modeled it to see how long it would take to produce the 30 design types of each. 30 units of each design type. And then we looked at how do we now optimize this production system such that we accelerate the completion of these units and therefore the overall schedule. After understanding that, we then went on to deploy product production control. That was what we want to do. Let me just talk through this approach. So what were we confronted with by the engineering team? Okay, so now we're moving away from the client context to actually the specific project team and the pain points that they had. When we started engaging with this team, we found that the engineering team said that the tasks that they needed to do to complete engineering were either not fully defined, were not aligned, as in who was doing it, what were the handoffs, or in some cases, we even found that tasks were not even known. We also saw that there was a siloed approach. So we saw that it was too infrequent or inefficient interaction and alignment between individuals and subteams. There was a fragmentation of resources. So we saw critical people that were required for a specific step in that engineering process having to choose themselves how to optimize their time allocation between different tasks and different design types. We also heard from the team that they had zero early warning or visibility on risk of delays, right? So they were always being surprised by further delays. We also saw a strong focus on excuses. It wasn't me, it was because of this, something went wrong, we should have done this different 2 years ago, etc., right? And not really a ability to address the root causes for delays when looking at individual task execution. And we also saw a buildup of work in process, i.e. Designs getting started and deliverables taking longer and longer and longer. So this was the challenges experienced by the product team. And to be honest, these are challenges that I have come across more often in very different parts of a project lifecycle. This really happens more often. So what did we do? We started with detailed production mapping, right, to set the stage. And maybe to clarify what we did. So what you see here is a representation of a standard engineering process for one design type, okay? And each of the boxes is an operation. So what type of operation might you have? For example, drafting a high-level design doc, or obtaining a quote or a statement needed for a site surveying so that they get the input for the design, or producing a certain specific detailed design doc, or reviewing updated requirements. Those are types of operations that were part of this standard engineering process for a design type. And each role was a team, and I'll get back to that in a minute. So what did the production mapping capture? So the production mapping captured what are the activity sequences and the handoffs inside this production system. We also got what is the workload and the level of effort needed for each of the operations. So how much does it take in terms of man hours a specific individual to do a task? And then we looked at what are the capacity constraints when we're looking across all the members of a team and therefore the capacity of the total system. Then we also understood other variables like what was the typical variability when executing a task. So again, we would try and understand when we draft a high-level design doc, how long does that take a team member to actually do? So with that, that's the information that we tried to capture with the production mapping. Now the interesting thing was that step alone was already considered as extremely valuable by the project team itself. Right? You can see some quotes on the right-hand side. Right? We had engineers expressing that, that the exercise was extremely helpful in defining the required work to deliver. Mind you, this was after 1.5 years that they were already working, right? A breath of fresh air to understand what we actually need to get done, right? So again, in the PPM framework, this really clarified how they actually were able to deliver their work. What we then did from a production system optimization perspective, this was a static analysis. So what we looked at is where would we expect the bottlenecks to emerge in the production system of each of the design types. So we looked at what is the peak throughput, which is the dotted line the number of designs that we needed to get through in a particular period of time to meet the schedule need, right? So the schedule determines the demand. That we translate into peak throughput need. And then we looked at, if we understand how much work it takes, right, and how much capacity it takes to produce a unit by a team for each operation, we could already do a static analysis and understand where the likely bottlenecks were. So that's what we did here. Yeah, and what we could see was that in all cases, so design type 1, 2, and 3, we had bottlenecks, which meant that there was no way we would meet the needed peak throughput, right? So we knew that we were in trouble already just from that analysis. What we also saw was that design type 1 was constrained by the capacity of team 2, and therefore that was the peak number of units that they could produce. Similarly, design type 2 was constrained by team 3 and 4. Design type 3, the throughput was constrained by team 1. So we were much better able to understand which teams were likely to be the bottlenecks that we had to address. What we also saw is that team 7 had structural shortage of capacity across all 3 design types. So again, we could start to figure out what do we need to do in terms of capacity in our different teams, yeah, to start doing that. And just so you're clear what the teams were, so for example, one team had to engineer the solution, so the design type, I should say, one team had to engineer the design type, so the equipment. One team had to do the specific site design, so making sure that the electrical and the foundations and all that was in order for that site. There was one team that was looking at safety needs. There was one team looking at supply chain, etc. So those were the types of teams having to do operations in that production system. We then said, we then said, okay, this is a static analysis, but given that this is grounded in operation science, we can actually model the system. So we used, right, so in the beginning, Gary did, ask which of these graphs represent what happened, the relationships, the formulas. You can also take that one step further. Professor Spearman is fantastic together with Dr. Chu in this, right? And they help model what the, or basically help model the production system. So we use what's called a dynamic model. And what you can see here is you will see a simplified dynamic run of 7 designs running through the system. I'm just going to let it run, and you'll see what happens as a result. As I said, each row is a team, and every design is running through this production system. Now, I'll just pause it for a minute. So what you'll see is a design consists of different parts that different team members have to work on for their specific durations, okay? So here you can see the different parts of the design or the task that has to be done being given to each of the individual teams. And what that meant was that this model could not only tell us how long would it take for one design to go through the full production system, it could also tell us at what point do we start seeing bottlenecks emerge as we increase the number of designs. And then with that insight, we could also understand how long it would take the production system to complete all units depending on the frequency of starts we choose. Okay, so this was a science-based approach with data and assumptions that we could verify that could allow us to model how long it would take the complete production system to complete all designs, which was a massively important insight because this is very different from our typical Monte Carlo simulations, which are based on assumptions that are much harder to verify and don't really mean anything. Yeah. So with that, you could see where the bottlenecks emerge. These are the red dots. So we could see that in team 3, right, the number of tasks that had to be executed at a certain point in time meant that designs were starting to run into delays and were starting to end up in inventory. And that was a very important insight because, again, we could be much more targeted on what to address. So, as I said, the dynamic model was able to predict the total outcome. So when we looked at the project schedule and we had looked at the cumulative engineering process, the baseline schedule suggested or was put that they would complete all 30X designs in month number 30 from the time that they started. Through the dynamic model, we could show that based on their assumptions, their data, the projected output with their intended frequency of starts would put them back 5 months. And we would also see that there would be a constant backlog in engineering progress against plan. So they would always be, except for months 8 and 9, right? They would always be running behind. And that was an important insight for them. But what was more important is we could actually think, how do we optimize it? So because we now had a functioning model that was based on the actual production system that the team expressed they were using, we could look at how to optimize both the cycle time and the throughput. So we could optimize width, right? We could look at what is the optimum level of width to get the optimal cycle time across the units. We could also fine tune the steps. So we could look at specific parts of the production system and choose to resequence, redesign. We could also choose to selectively adjust resource. So as you remember from our static analysis, and also from the dynamic model, we could see specifically which team needed an additional resource to get more throughput at an aggregate level. We could also, instead of adding resources, choose, instead of adding a resource, why don't we go into that operation or that set of operations and actually take out waste in the classic lean sense. And lastly, we looked at what kinds of mindset and behavior improvements could we do to ensure greater reliability when it comes to completing tasks as agreed. So those are some of the things that we had in mind. And so that's what we worked through with the product team. And then we got to the following, right? The model showed that if we would cap the width at less than they were doing, okay, and I've sanitized it, but effectively we were reducing, I believe, the width by around 30 to 40% with what they thought they should have, or what they were planning to start, I should say. So by starting less, the model showed we would finish sooner. This was a super counterintuitive insight for the project team. We also looked at the longest chain of tasks in sequence, right? And we saw that one of the key things was the review times from the owner, okay? So what we showed to the contractor is that if they would be able to engage the owner on reducing their review times and the variability of their review times by 50%, that would help expedite the engineering phase of the project. So it would be in the owner team's own interest to try and improve their performance. And then we also looked at the effect of adding specific resource in the bottleneck teams. And we saw that the combined effect of a width cap, improving owner team review times and the additional resources, according to the model, was actually sufficient to pull back the delay, right? So we had relatively minor tweaks that weren't too invasive for the team, actually showing a material performance benefit for the product as an aggregate. With that in mind, with that optimized, sorry?
2 minutes left for the wrap up.
All right, sorry, yeah. And so, with that in mind, we then started, hey, we now have a production system that shows we can finish on time. And that's when we switched to PPC to really drive the daily work and to ensure that that potential identified was actually captured. And that's how we then progressed the work. So overall, right, so PPM really brought tangible benefits. We mapped the standard engineering process for the 3 designs. We used the dynamic simulation model to identify the bottlenecks. We identified specific initiatives to optimize the process. We then established a weekly production control. We trained several clients in using that production control, and ultimately we de-risked the schedule by 5 months. And it was something that, was a tremendous experience together with the folks from SPS. Sorry, I didn't manage. I hope I managed time. But,
yeah, thank you, Jan. So I appreciate it. So very, very interesting and compelling story, especially how you have used technology, the simulation engine that was built and the visual display in order for the project team to actually visualize the output of the application of EPM and how they can actually optimize it. Very, very impressive. We do have actually several questions here for you, and let's spend 5 minutes, the 5 minutes that we have left in your section, to go through them very quickly. The first one, let me see if I can combine a couple of them. So the question is, can you please elaborate more on the difference between the dynamic modeling you used and typical Monte Carlo simulations?
Yeah, and Roberto, you might have to help me here when you talk about Monte Carlo. But so the Monte Carlo is a simulation still based in deterministic is a deterministic basis in which we take a activity and try and estimate or try and put in some kind of plus minus duration. So it could be 20% longer, it could be 10% shorter. You know, we take these guesses on what the difference of an activity is, and then we run this network, or like this, the Monte Carlos, and we run it 1,000 times, and then we look at the probabilities of how long a schedule takes. But the problem is that there's no actual basis for understanding that range, and it's also the events that get you off are not the ones that are inside the 2 sigma, but it's the tail events that mess things up. Okay, and this is where the Monte Carlo simulation falls short in helping truly understand how long it will take a project to complete, right? And this is, you take the opposite, you look at the production system approach, right, which is based on, and I don't know whether you've experienced it or to what extent, but these are scientific formulas based on actual measurable data. You can measure how long it takes a task, you can measure how long the variabilities of the task, and therefore science dictates how long it takes to produce the unit. There is no assumptions, there's no unverifiable assumptions in that. Yeah, and so it's maybe
one thing that I can follow in your request for me to jump in. It's important that what our audience understand is that what you were showing is not a schedule. What you were showing is a production process within a given system in an engineering, right? So the typical application of Monte Carlo simulation are on schedules, right? And there are several tools available in order to do that. But what you have done, Jan, for this particular challenge was to go to the production system, not to the schedule, and understand the throughput, the width, the reasons for playing with variability, and also use the science behind it, right? So there's another question. We can probably go for two questions. I'm going to combine these 2 questions because one refers to, what is the simulation tool that you used, and then also is what is the tool that was used for the visual, right? It seems that these individuals understand that they're 2 separate things. So I'll leave that with you.
So we use the production system optimization module from SPS. And Roberto, what's the official name, so I don't say it wrong?
It's a production system optimizer, production optimizer.
Yeah, production optimizer, right? So we use production optimizer from SPS. And then, to be honest, the visualization that we made was actually made to, we took timestamps, which we can get, and you can read out, because again, at any given time, you can understand where your inventory is because it's based on the operational science and these formulas. So we took timestamps, and then we just asked our visual aids to visualize and model on the basis of these timestamps where our inventory was at any given time, and that's how they gave it back. So the visualization was purely to actually share the story of how inventory flows through the production system. That's
Excellent.
frankly the yeah.
We have let's go for one more question. So there's one here that says, you mentioned the model predicted a 5-month schedule delay, which is great. And so this person is wondering why an approach like this is not used more often. Thoughts?
Yeah. So my thought on this is it's a very good question. After we did this, right? For us, it was an extremely powerful insight that we can actually baseline a expected project outcome on the basis of science and verifiable data. That was a tremendously impactful insight, and the ability to then take a model and make adjustments in a virtual environment before actually implementing it in practice, so that you can go through a lot more iterations to figure out how you really get to that optimized outcome. I think, yeah, I think the more people will see it and hear it, I think the more it'll be applied. I think it's an extremely powerful way to think through project execution.
Excellent. Thank you so much, Jan, for
it should be used more.
Thank you so much for you answering the questions, and thanks for joining us today. I mean, the results that you have and the approach actually that you have shown us and how you have done it it's quite important and interesting. I personally like, again, the way the display worked out and how you and your team did it. So very, very nice. Conscious of time, we need to transition. Thank you so much, Jan. We need to transition. Thank you. We need to transition to our last speaker in this session. It is my pleasure. Thank you, Alex, for showing your screen, and we can probably hear you as well. Checking.
Good morning.
Great. So let me quickly introduce Alex Koons. Alex is a principal at AG Koons, a company focused on systemizing the construction industry to an integrated approach to design and construction. Alex is joining us from Silicon Valley, California today. He will share his perspective on integrated design and construction and how this is being achieved in data center infrastructure delivery. Okay, a bit more about Alex very quickly. Alex and his company are particularly focused on the global data center industry, and today he's obviously talking about that. He's going to share with us what he's doing with model-based design, analytics, and the application of project production management. Alex is a member of the Project Production Institute Industry Council. He has extensive amount of experience in delivery. Professionally, in terms of who he is a bit more, he received a Bachelor of Science degree in Mechanical Engineering from Cornell University. He is also a professional engineer in the state of Colorado. He led the services group at Gary Technologies for several years. And prior to that, he has actually deployed PPM-based solutions, including computer-aided production engineering at projects such as Heathrow Terminal 5, which, by the way, is where I met Alex back in 2003. So yes, 17 years ago. It's amazing. Alex, it is great to have you here, and welcome to the 2020 annual PPI Symposium. And please proceed to share your screen. And the stage is yours. We can see it now. Thank you.
Outstanding. Thank you, Roberto. And thank you, PPI. I'm glad to be here. And it's my duty to say I'm the last presentation standing between you and the lunch buffet, or the breakfast buffet, or the dinner buffet, wherever you may be. So let's have some fun. We'll talk about data centers and our work on the design and construction of these amazing products that are very much a part of our time and have seen dramatically increased usage in the last couple of months. So as we say, the fundamentals are quite strong in the data center industry right now, but we're faced with tremendous difficulty in the execution side right now. Our work is really focused on the what and the how. What's in the box, as we say, what's in the data center design, and then how are we going to build it? And we're less focused on the who and the when. As Roberto said, I started my career on projects like Heathrow, where we did encounter enormous infrastructures of schedulers focused on who and when, wondering why their projects were chronically late and unpredictably expensive. So we use the PPI framework as a company today. We're very focused on simulation, visualization, virtual and mixed reality, things like that. We're very much as just a part of our daily work focused on model-based design. We build computer models, 3D computer models for everything. And as we've extended that work across multiple projects, the opportunity for analytics presents itself. And our clients ask things like, hey, it takes me 3 to 6 months to get a cost estimate. And we say, well, that should take 2 minutes. We have all this data. We're very focused up front on model-based design. Analytics should just play a daily role in what we're doing. So we introduced that. As we've had more and more data extended out across our program of projects, the opportunities for machine learning have presented themselves for using reality capture, 3D scanning, things like that, for controlling execution in the field and really just verifying what's there and does it comply with design intent. That's a big part of our work now. And then we'll get into robotic process automation towards the end of our slides. So why are we here? What's the big deal? Our clients are looking for really 3 things. One is time to market to satisfy their customer demand. And as you could imagine, the demand for cloud services is exploding. So customers are banging down the door saying, I want more. There's also a very fertile marketplace with a lot of competition right now. We're going to look at what that means, but competition for cloud services between Amazon, Microsoft, Oracle, Google, IBM is tremendous right now. The industry is faced with a developing supply chain. And we're going to talk about what that looks like in a second. It really begins with AWS pioneering data centers for cloud really not that long ago. So the supply chain, we shouldn't use words like it's immature. We're just building a product that simply didn't exist 20 years ago at the scale that we're doing it now. And some numbers to present how large the marketplace is around the world and its growth rate. It's maybe less important what the actual figures are, but they're growing. They're tremendous in scale, and the opportunity for success or failure is huge. So let's talk about what the data center is. There's a seminal book called The Data Center as a Computer. That's what this diagram is taken from. It's an incredible read on the role of and the development of warehouse scale computing and the architecture of the data center effectively as a computer. And you can begin to interpret these massive facilities as a computer with a motherboard and various nodes attached to it. We see the scale on the right side here, just for context, that there's enough power going into that building that could alternately power a small city. And then the sites for the big tech companies that are building these data centers, they'll put multiple of those on one site. So big facilities, lots of infrastructure. It's largely about power, moving electrons into the computers for processing, and then evacuating heat. And there's so much heat that we can't just use air to get it out. There's a tremendous amount of processed water systems. So that's why we have cooling towers, chillers, things like that, that are extracting the heat out from the facilities. So the approach over time has developed. It was a little Wild West, really not long ago when Roberto and I were building airports and working on other kinds of projects. There was a early set of pioneers building out these massive scale data centers for the first time, based on learning from IBM and others who had been building compute centers for quite some time. Even as a kid, I remember going into my father's computer. It was the size of a room. It was at California Pacific Medical Center, and it had less RAM than what's in our telephone today. The early pioneers really just got it done. There wasn't so much focus on how the building was put together. The demand for search and ads far exceeded any systematizing. As the tech companies began to mature, there was a focus on regional program management, very conventional establishment of project controls groups to manage execution and to manage contracts. And the consequence of that was predictable unpredictability in cost, schedule, and in the finished product. And we could describe that as the snowflake era, where many of the data centers being built look different for a variety of reasons. And our go forward plan in our work with our clients is on developing a global production system. And let's talk about what that looks like. There's more artifacts on the scale of what we're up against. When we talk about the production system, there's three things that we're introducing into the program. The objective is to drive predictability, reuse, to free up cash so it's not tied up so early in design, and to accelerate design and construction. So there's three vectors, three techniques that we're using so far: product architecture, configuration-based design, and then industrializing the manufacture, the production delivery. So first topic we'll touch on, product architecture. Stephen Eppinger and Carl Ulrich out of MIT have some really great courses and books and knowledge on just this concept of product architecture. And it's really the work breakdown structure, but in a physical sense, or the arrangement of functional elements into the chunks of the building. And they cite three different types between slot, bus, section. If we were all in a room, I'd ask a question: what do you think a building fits into? In this environment, I'll just discuss it a little bit. Most of our buildings tend to be slot modular. We build a steel structure, and then it has unique interfaces for every building system that connects to it. And the consequence of that is if you take a system out, you can't put a different one in. They're all unique. That's not a big problem for a house or for a building occupied by people, that we don't change that often. Data centers are rapidly evolving. So we want some ability to change the constituent products inside it for upgrades. So we're more interested in bus or section modular approaches to design. Now, Eppinger and Ulrich looked at the building industry, and this is what they found. Inevitably, they're looking for this. They're looking for something that's more architected with predictable interfaces. And this diagram on the right is just exemplary. It probably exists in the schedule for this example on the left, but in the physical product, it's a spaghetti. And we're in the business of learning from other industries and applying a cohesive approach to the product design and the architecture from the start. So here's an example from Volvo. Automotive makers famously build 60, 70 plus product types from one chassis. That's the role of product architecture. There's a lot to be learned from the mountain bike industry. This is an example of the first production mountain bike from 1979 with Joe Breezer. There's been a tremendous amount of innovation in that space. And to highlight what's most important here is the industry developed incredible new products that are faster, lighter, stronger. But the real lasting consequence was their development of industry standards. So there's over 20 companies that contribute products to the bicycle on the right here. from a global supply chain. And the industry was able to get together and get behind a series of geometric standards that allowed supply chains to flourish and to create a variety of products that give the customer more choice at less price. And we're looking to do just that in the data center industry as well. I mean, it's not a mountain bike. This is what our products tend to look like. This is what's getting built. Now, where we're going in the data center industry, if we extend this product architecture concept, is that in most conventional practices, there's a lot of focus on the individual parts in the equipment and these pieces that we buy from stock and then their configuration. And there's really less emphasis on productizing what sits in the middle. That's considered intellectual property. That's competitive advantage. And what we're seeing is an opportunity to begin bundling more and more of the parts and equipment into built up larger products for power distribution, for cooling. And the use of standards will allow us to increase the supply chain as well. We use some techniques and tools from companies like ID Consult that are based in Germany, who have software that's been very effective at creating maps for defining product architecture, and then building links between the functional requirements and product design. The reason why we do all of this is to get to configuration-based design. We don't want our designs to take on the order of months to years, but we think we can accelerate that by having a configuration approach as opposed to a more invention-based and design-based approach. So we use PLM systems for that. They capture the product and the process, creates a catalog. The whole point of doing that is to get to a vision of designing the data center in a day. If our current order of magnitude to design the facility is on the order of months to years, but the program is going worldwide, we really need to find ways to accelerate that, create reuse, allow the production system to behave a little bit more like Toyota building Tacoma trucks, as opposed to the current one-off snowflake era. So tying the configuration-based approach that we have to design into execution, we're interested in how we move artisanal, handcrafted construction from the field upstream into the factory. And we want to know, how can we apply robotics and things like that? And also shift from a more conventional approach focused on schedule and resource utilization towards product and process design, and then management of these levers around capacity, inventory, and variability, which we've traditionally not had visibility into. From the owner side, you're typically buying an outcome and you don't have ability to get into that. And so what we see on our programs is owners bringing the supply chain in closer to start defining what should the capacity, inventory, and variability, how are we going to manage for variability at the point of installation and even upstream into the factory. And in the data center space where the supply chain is developing, I wouldn't say it's immature, but it's open to growth. We're finding effectively open arms saying, yeah, let's do this together. So we're interested in robotics like anybody else. So our first step was to begin buying some robots and start exploring their application for aiding in assembly. And what we find is that immediately drives a change in the product design. And this is the beginning of our use of what models look like on the left side that you see here. But as soon as we begin mapping the process and then tying it to the product, we immediately start changing the product. So as PPI would say, we're applying concurrent engineering, product and process at the same time, where the process informs the product and vice versa. And we find this of particular importance in designing what throughput do we need and what capacity do we actually need. And this has allowed us to take our projects from a more conventional bidding procedure, where a contractor is buying the job, where we flip that around and we're now able to sell the job. We have the product, We have the data behind the product. We know with vicious accuracy what's inside the box, down to the bill of materials level of detail. So knowing that, we're then able to sell the job and then work with the supply chain on designing what is the throughput that we need to hit the milestone objectives. And in the face of that, our milestones are able to be defined by what the customer actually needs, as opposed to what the project will support. So we're now in the process of crafting not just what the field looks like, but what the factories that produce products for data centers begin to look like as well. So we've taken our product data and started crafting virtual factories around them, and we'll be building out these actual factories entering into 2021 this year. Roberto, that's my last slide.
Excellent, Alex. This is quite impressive. So thank you so much. Very impressive stuff. No doubt you have not stopped innovating over the years since we both met back in 2003. So look, we have a few questions here for you, and we have also a few minutes left. So let's go through some of them. The first one here is the vision that you brought to us today. Do you think is applicable to oil and gas, or do you think this is something particular to the characteristics of data centers? Somebody asked.
Yeah, data centers are fascinating because they're like a Swiss watch on the inside, and the profile in our company, they're mostly mechanical engineers. We have a handful of architects too, and we have them architecting systems. And we're very focused on projects that are not occupied by people. We've actually done some work in conjunction with SPS in the oil and gas industry. And so, yes, I think it lends itself very well to productizing its work, and particularly anything involved in interface management, where you're just trying to bring system noise down in the product designs so that you have consistent interfaces, not knowing what the next generation of product may bring. That lends itself really well. And what we're finding is that as we stay upstream on the design side, we make the work of applying PPM in the production sense and in the field much easier, because we've stabilized the product design.
Excellent. So one thing that you mentioned that really it seems that is taking people's attention is this idea of concurrency between process design and product design, right? Because I think one of the messages you share with us is that it's not just about standardizing the product, right? Meaning what we're building in the case of your story in data center construction. So can you tell us more about this comment you made? The question is the concurrency, and sometimes people are saying it's difficult to do. So what is your take on that?
It is, but we all grew up as builders, so we can't even look at a design without thinking about how is that going to be built. And in the case of our customers, they've just simply had to decide, are they in the business of regional program management, which is a contractual function, more economic than technical, or are they in the business of designing and managing a production system? And if it's the former, they really never need to even see the design or the schedule. And if it's it will have unpredictable results. And if it's the latter, then you really need to get way deep in the design as the owner team, because you hold the requirements and then develop concurrently the products in the process. And what we've been doing is cataloging not just reusable product designs, but reusable processes.
Excellent. Yeah. So, in my experience as well, if we sort of share some thoughts, I mean, there's a lot of blind spots, I think, in project teams when they look at the processes required to execute the projects, right? And we're not talking about the schedules, right? Because we're talking about how you do things, right? And I think that's the animation you show us is quite impressive, because that is how you're making things, how you're engineering things, how you're installing things, right? Especially coming from owners, right? Those that own the data centers. So the other comment you made that also personally took my attention is that what you're telling us that owners are not really waiting for contractors to do this. They are taking the bull by the horns, if we can use that saying, and because it's their money, because it's their capital, and they're looking for more efficiency. Is that true?
Absolutely. Yeah, absolutely.
Okay.
Particularly for complex capital projects. And in the case of a data center, half the products going in are designed by the owner themselves, meaning computer racks and servers. There's an incredible agency called Open Compute Organization that's looking to share industry best practices in the hardware space around racks. They're now pointing their attention up above the racks to the cooling and power distribution, simply because the demand far exceeds capacity. And in the Wild West, early 2000s era, it was, as Roberto said, it was owners procuring turnkey projects and simply hoping for the best. And now, as the organizations and enterprises have become much more sophisticated, there's a lot more emphasis on controlling the system as a whole, the product and the process.
Okay. Thank you, Alex. We do have a couple more questions here for you. One is, it seems the tools you're using are not for 3D modeling, are not conventional tools, or they seem not to be the ones we typically know. What are you using?
So in practice, just about everything. Revit, we coordinate Navisworks, AutoCAD, we see Bentley. In our house, we have Revit, AutoCAD, SolidWorks, Siemens NX, Creo, Inventor, you name it. And what we're finding is that's less of an issue. And we have lots to say on this topic, far more than we could get to here. One axiom is that there's always a design model, which is the intent, and that tends to be symbolic in nature. And that's AutoCAD, Revit, Bentley, that kind of thing. Then there's an execution model. That's the real data that the machine uses to cut or bend or weld. And we need both. So none of us should be in the business of trying to create one model. There is no one model. There's one data set. There's one platform to host it. But there will always just axiomatically be design intent versus execution. And we need both, and we're very focused on the dance between the two, and then ensuring that the execution data is sufficient to drive the machines creating these high precision parts that we assemble into a data center.
Thank you. There's one more for you, and I think with this one we finish before we go for the break. The question is, since your work seems to be with owners of data centers, would you mind to share with us a few aha moments that you and your team might have experienced by working with, well, actually that your customers might have experienced when going through this integrated design and construction process, it says? What can you tell us about it?
Yeah, we were super lucky with one particular owner who said, why don't you just come here for 3 months and look around. I think we said, why don't we go there for 3 months and just look around? And we were really fortunate to be able to just observe. And most of the time, owner teams are engaging companies with a fixed deliverable, and then there's this immediate rush to get something done. And that begins to create certain behavior. And the first aha moment, we showed up and said, well, show us the design. And no one could really find the design because the designs were somewhere else. They were in the hands of the EPCs and the AEs, and well, they're in another state, and that guy left the company. And it was remarkable how the actual data was just out of control. It was not there. And so one of the first things we did to the patient was work with owner teams to put in place systems that just bring everything back in-house. Once it's in-house, you can unleash the analytics robots that poke around and say, hey, look, you got 25 projects. We expect to see 5% variation across them, but we're seeing 80%. They're all different. Don't we want them to be similar or more similar? And so by bringing all that data in-house, you get much more opportunities for that.
Great, thank you. I think we have probably a minute. Maybe we use that to ask you one more question. The question seems to be about what happens when a standard design of, in this case, I'm assuming it's a data center, as you shared with us, needs to be built in different locations, and there are actually localization requirements that owners need to go through. So is that turning the standard design into a non-standard design? What can you say about that?
Yeah, we plan for that. There's multiple layers of this. From a regional perspective, what you need to do in Europe is simply different than what you need to do in the US. But that tends to affect the boundary conditions of the total product. And what's happening on the inside is a little bit less unique at that point. We have some projects that assemble modules in the US and then ship them back to Europe. So for us, I think we view it as another entry in the catalog. From the production system, it's just another module coming through. And then if it gets shipped abroad or gets shipped locally, that's a decision held as late as possible in the process.
Excellent. Well, Alex, conscious of time, I want to really thank you a lot for joining us this morning. Good to see you, and after so much time, and for sharing your vision of, for some people might be a vision, for you is something happening. For some of the company you're working with, it is happening. It's happening now. For others, might be perhaps your presentation has been what could be done, right? And thank you very much again for being with us. So always learning new things from you. That's always good. Look, after listening to so many inspiring stories of application in design and engineering, I think it's now time for us to close this morning session.